Good afternoon, everyone. Here's Hansa Raqiq from ZeMA. I'm the lead of the RICAIP project at the ZeMA end. And first, I would like to welcome you to this first session of the RICAIP seminar series. Few organizational information before we get into the core of the topic. First, this meeting is being live streamed on YouTube and being also recorded, just so you know. And at the beginning, the participants would be muted. So if you have any questions throughout the presentation, feel free to write them down in the chat. My colleague Teresa would take note of those and we can answer them after the presentation. And during the discussion session, you can then just unmute yourself and ask the questions whenever relevant. So today's talk would be about sustainability. And the title, as you can see here, is Towards Environmental Sustainability, Electrification of Transmission System E-Trans. And it will be presented by Dr. Bassem HICHRI, who is a doctor in multimobile robotic systems. He started his career in automotive industry as a test solution engineer, then worked for quite some time in academia. Maybe if some people at ZeMA already know him as he was our partner in the Robotics Academy project for a long time. So he was a postdoc also in the Luxembourg University for a couple of years, and there had the chance to manage multiple research and development projects. So currently he is managing research and development activities in a new research center of Carraro Group in Luxembourg. He will be also presenting the group himself. So the aim is to develop commercial electrified drivetrains for OEMs of medium and heavy duty vehicles, which contributes to the European challenge of reducing CO2 emissions and environmental challenges by providing solutions, mainly e-transmission and e-trans axles for construction equipment, vehicles, and fully electrified tractors. So with that, I'll give the word to Bassem. Hello, Bassem.
Hi, thank you so much for this presentation, and it's a great pleasure to be again involved in some activities with ZeMA. So yeah, as you were mentioning, so my presentation today has the title of Towards Environmental Sustainability about Electrification of Transmission Systems and Drivelines for Construction Equipment and for Agriculture Application. So the outline of my presentation today, it will be as follows. So I will start by a general presentation of Carraro Group, and then I move specifically to present our R&D entity in Luxembourg, which is newly established here since 2 years only. Then I will provide just small market insight about the tendency to electrify construction equipment and agricultural tractors. And then I will talk specifically about the specs of E-Trans project and the achievements that we reached now for 1.5 years work in this project. So as a start, I would like to have an insight about Carraro Group, which is established on 1932, and then changing the type of business from B2C to B2B on 1980. And with the aim of expanding the group on December 95, the holding company Carraro SPA was listed on the Milan Stock Exchange, and this was a new turning point, starting the group down a path of growth and production expansion well beyond the national borders, the Italian borders. And on 1997, so Carraro Group launched the internationalization phase, with the first industrial plant that is launched in India, and in short time, the group was expanding the production, reaching the North and South of America as well on 2000. So the international expansion phase reached its peak between 2006 and 2007 with the establishment of the Carraro Technology India R&D Centre, and the inauguration of the new production site in India and in China also. So on November 2011, the group decided to involve all employees, over 4,000 people, in Carraro Value program. And in more recent years, in fact, the group continued to seek maximum efficiency of its product. And today we are developing the transmission and integrated system that are increasingly oriented toward efficiency and eco-compatibility. And on the last years, on 2021 mainly, so the group decided to launch new strategic plan, a solid basic on which the design or to design our future. As a key data related to the group, so we are processing mainly 9 plants, almost 4,000 collaborators, and the turnover, the latest one, it's 736.6 millions, which is in fact decreased by almost 13% compared to the last turnover of the last year by December 2023. And this was due to the drop in volume due to significant market downturn. So the last year, mainly, we were witnessing really a crisis related to our main market, which is agriculture. So talking about that, I move to the next slide, which is about our market and market share. And as you can see, mainly we work on agriculture and construction equipment applications with 35.2% related to construction equipment. And we provide different solutions, mainly related to the drivetrain, transmission, transaxles. The main activity of our group is related to agriculture sector with 48.6%, and the remaining is split between different annex activities, let's say, with a reduced percentage, mainly railway transport applications, material handling, automotive sector, and other fields like robotics and other machines requiring transmission systems. So in terms of markets, so as you can see in this map, so our products are mainly dedicated for European market with 53%, Asian to 30%, and to American market by 17%. In terms of global footprint, as you can see, Carraro Group is installed in the different continents with different placements and different type of plants for production, for drive lines and tractors, mainly in Italy. So in Italy, we have a specific plant that is called Agritalia to manufacture full tractors for its really small and medium tractors, and also plants for the production of the drive lines and gears production. We have also different engineering and R&D centers in different locations like Argentina, Luxembourg, Italy, India, and China. And also we have sales offices in different locations in the world. So our core business, as you can see in the slide, so we have mainly these areas where we are performing activities. So we have a specific plant in Italy for production of heavy-duty gears. So it's really producing and mainly manufacturing high-quality gears for OEMs in any sector, every sector. So we have all the different types of gears, bevel gears, cylindrical gears, or other specific gears that we provide to our customers. In terms of drive lines, we are tier 1 supplier for integrated power transmission solutions. So front axle, rear axle, and the transmission system based on different technologies. As I was mentioning in the previous slide, so we have a specific plant for production and manufacturing of full tractors dedicated to agriculture field, and we also can provide specialized tractors for major OEMs. In the latest years, we are also working on the e-power systems while considering the electrical motor technologies, the batteries, power electric. We also work on hardware design and software and firmware design, and also we develop our internal activities related to data collection for mainly predictive maintenance related to our products. So of course we have our spare parts offices and after-sales services that we can provide to all our customers. In the next slide, so I'm showing here the based on each sector, our main customers. As you can see, we have big names for construction equipment, drivelines, and others like Caterpillar, Volvo, CNH, John Deere. And in the last 2 years, we also launched a new plant for production of rear and front axles for Ineos. And it's the first automotive sector, but it's off-road cars. Acting in all-terrain cars, but it has similar aspects like medium and heavy-duty vehicles, and that's why we had a huge new contract with Ineos, and we are now manufacturing the front and rear axle for this type of cars. We also, in agriculture drivelines, we have big names like Claas, John Deere, Mahindra, where we produce the different systems related to the driveline, specialized tractors, Claas, John Deere mainly, and also for the gears, we are provider for the different types of gears and components needed for the transmission systems to our different customers. So this was about Carraro Group. Now I'm moving to talk more specifically to Carraro Lux-Tech R&D Centre in Luxembourg, which was launched on February 2023. So it's almost now 2 years working and performing engineering activities and mainly R&D activities. And the specialty of this new center is to execute and to bring to real life the new ideas and projects of Carraro Group related to electrification of drivelines and drivetrains. So it's mainly about developing electrified transmissions using electrical motors and to develop connected machines, allowing to gather data for predictive maintenance issues. And we work also in close collaboration with universities and public institutions to develop e-actuators, mainly electrical motors with new technologies. And of course, in our team, we have the staff specialized in developing the software and control aspects all behind the hardware that we are developing. So we have actually a team of 5 members. I'm dealing with our new projects and R&D activities. We have a CTO and a general manager who is mainly coaching and following up all the technical aspects related to the development of our systems. We have mechanical engineer, we have system engineer, and we have testing engineer who can perform all the activities related to the development in terms of mechanical design, electrical design, and control and software development, which are needed and which covers all the aspects related to our product. So here, the scope and the target market. So it's about off-highway market, which is undergoing a similar path as on-highway, the normal passenger cars regarding electrification. Although the off-highway market has a longer elapse of time, and it has significant difference driven by specific aspects, which we call mission profiles of several types of equipment. So if we talk about normal passenger car, it's supposed to be running and driven in the road. Although for the off-highway equipment, if we talk about construction equipment, for example, it's dedicated to perform specific tasks, which we call the mission profile. So it can make some works in a specific field. It can go to run in roads, and based on that, this makes the difference and brings more challenges in terms of electrification of these equipment. So electrification is realized sooner and is economically sustainable in compact equipment. So we are targeting mainly small to medium construction equipment and tractors, which can be easily, let's say, electrified compared to really heavy vehicles. And today, there are already several examples of compact equipment in production, and they are actually using batteries and electrified solutions. So, and the goal of our center here is to design an innovative, either hybrid or electrified transmission for construction and agriculture application. So here's just a small table summarizing an internal study that was made by our group. It's about the electrification tendency between 2021 and 2030 related to construction equipment with some specific targeted vehicles and applications. It's about mini loaders, compact truck loaders, mini excavator, backhoe loaders, side dumpers, walk behind compactors, and telescopic handlers. And these equipment are expected to move from 0% electrified equipment to maximum 25%. And also in terms of agriculture equipment and agriculture vehicles, it's about tractors with different horsepowers, some specific agriculture equipment. And here the electrification from 2021 to 2030 will be evolving between 0% and 50%, like the high clearance tractors. So as you can see here, so the market is really huge, and we tried to be more, not the first one, but listed in the list of the first companies who are moving toward this new market and to the new electrified system dedicated to these markets. So after giving this insight, now I'm moving to talk specifically about the first project that we are developing actually in our R&D center. It's called eTrans, Electrified Transmission for Medium and Heavy Duty Vehicles. And we were motivated, in fact, the first thing that medium and heavy duty vehicles, they are responsible of a major part of greenhouse gas emission and harmful particles emissions. And one of the main target is to reduce CO2 emission and air pollution and to seek for cleaner and more sustainable future. Our motivation is also guided by the customer demand, but to improve public health and awareness of the environmental issues. And also, as we see for passenger cars, so there are government policies to promote the electrification. And yeah, so it's all related to these new rules, and we are motivated by this one. In terms of challenges related to eTrans, we would like to identify identification of product architecture for physical validation, which will represent a new generation of heavy-duty drivetrains, and name the key design parameters to optimize the transmission. We would like to adapt the product architecture to customer needs, so we're offering a solution that allows to satisfy a set of customer needs. So for this eTrans project, the customer can select different features in the transmissions. For example, can use 1-speed or 2-speed version. In terms of shifting, he can select either to use synchro shifting or power shifting. So also there are several options like the 2-wheel drive or 4-wheel drives, and also park brakes. So I will show this more in the architecture of the system later. But here I just wanted to mention that this product is really can be tailored and adapted to specific customer needs. We are also providing, in terms of customer needs, a similar shape for different versions that also I will show later, where the customer can use the same system either in a vehicle fully electrified or a hybrid vehicle. The transmission also can be placed in different configurations. It will be much more clear in the next slides. And the next point, the next challenge is related to the development of a real-time simulation environment for a faster and more efficient development process. So it's a flexible asset for rapidly validating new architectures and control algorithms for academic publications and industrial patents. We also develop a measurement setup and physical test benches that are adequately precise and reliable for the experimental verification cycle. And finally, we aim to design e-motors, their power supply controllers and driveline that will allow maximizing the overall performance while minimizing the space and cost at the same time. So about the description of the system itself. So it's a design of a versatile 2-speed gearbox able to fit both construction equipment and agriculture application from 50 kilowatt to 120 kilowatt with a maximum speed of 45 kilometers per hour. We are offering two versions, hydrostatic or electrical, using hydrostatic or electrical drive. It is proposed to ease the transition to electrified vehicles. So this project duration is 3 years, and it started officially on June 24, and it is supposed to end up on May 26. At the end of last year, 24, we have the prototypes available for customers to be tested and validated in real vehicle in the field, and the production is planned to be on the second half, in the second quarter of 2026. So during the development of this project, we were working closely with the suppliers and customers in order to perform to provide the suitable product based on our customers' needs and based on what is existing from our supplier in terms of technologies to be included in our systems. And the total cost of the project, it's around 4.6 million. So again, for the next slide. So here, a reminder about the specification of the vehicles where the system is supposed to be embedded. It's up to 13 tons machines where the system will be included. And as you can see on the right bottom side, the two versions where you can see the electric version using an electrical motor as input for the traction of the system, and the hydrostatic version where we are using a hydrostatic motor to ensure the traction. And this, as you can see, the two external envelopes of the two technologies is the same, which allows our customer to use either the electric or hydrostatic version. And here the difference is really inside the drop box, where we are mainly working on the gear ratio between the input shaft and the intermediate shaft. So, and this system, it was mainly developed after a huge deep market study on the existing solutions. As you can see on the left side, it's from our competitors, the different solutions which has the same specification of our product. So what is the plus related to our system? So here what I was mentioning in few slides before, that our core drop box, it can use two options, either the electrical motor or hydrostatic motor. We can also add different options like the parking brake module or the four-wheel drive, which allows the traction of the four wheels of the vehicle. Also, in terms of installation in the vehicle, it can be installed either on the vertical configuration or in horizontal configuration. So, and as you can see, here is the list of the different options that we can add to our central drop box, either using synchro shift or power shift for the shifting strategy, the different options related to the brake four-wheel drive, a specific lubrication pump that was developed internally by Carraro. So it's a specific pump that we call gerotor that allows the lubrication of the primary shaft, intermediate shaft, and output shaft, and the different ways of installation. And of course, which is very important to our customer, it's the ratio flexibility where we can adapt our system based on the requirement of our customer. Just talking a bit more specifically about this shifting strategy. So we developed an integrated control that allows to manage the shifting using the engine to synchronize the shafts during the shifting operation. In case we are using for our system the oil coming from the vehicle, if the oil pressure is not available, the transmission can operate as a standalone system. And in this version of transmission that we developed, we integrated the proportional valve and a linear sensor for the synchro shift system, and which provide the precise control for the shifting, and specific additional components as the accumulator that allow to use a small pump for the actuation and an external pump that provides oil pressure for actuation. So now I'm moving to talk a bit about the control side, where we develop, in addition to the hardware design, manufacturing, and testing, we are also working on providing the full solution also related to the software development. So our strategy to develop the software is using the model-based design for our system control, which consists of mathematical and visual method of addressing problems associated with designing complex control, signal processing, communication systems. And we are mainly using MATLAB for this as a software for this development, where we can model objects that can represent individual components of the control architecture, such as the actuators, the sensors, or the controllers. And we can connect the model objects to build aggregate models of block diagrams that represent the combined response of multiple elements. In terms of after making the model-based design, we also make the application and firmware code in order to integrate the embedded software in a specific control unit. It's not manufactured in our in-house, but we have specific partners with whom we are working for years now, and we are using their systems which are adapted to our developments and for our control of our equipments. In terms of functional safety framework, we are mainly working under different standards as ISO 19014 and 13849. In terms of software development, we are using the same strategy, the V-shape. So in the automotive sector, it's very well known as V-shape, or a model which stands for verification and validation. And it splits the development process into mainly two parts. So the left arm of the V consists of requirement analysis, function design, and software development, while the right side, it's mainly concentrated about the verification and validation activities. And as you can see for the validation side, so for the system validation, we are using a test bench that I will show in the next slides. For the system verification, it's about hardware in the loop. So we are mainly performing the test environment based on the correlation between the software and the results of the test bench. The same thing for integration. And the last point, it's about software, which is done mainly in a model and software in the loop. So talking about the testing and validation, we invested some quite money in building and developing a test bench for the experimental validation of the different equipment that we are developing in-house. And as I said, so the first product, it's e-trans, and this test bench is we are using the test bench to make functionality and durability tests for all the aspects related to the validation process of drive lines and transmission systems. And we, as you can see, so the system, it's composed of a central part, which is an electrical motor that allows to drive the transmission. And on the output, we have two big motors on the two sides. It's about simulating the real conditions of the vehicle or construction equipment in real conditions. So we have two motors that will simulate the real behavior of the vehicle in order to test the transmission in similar conditions as in field. So here you can see in the next slide, yeah, the two videos showing. Sorry. So here you can see the two videos. I don't know if it's moving.
It's not.
Yeah.
No, it's moving. It's
So here you can see the test bench running, and as you can see, we have a monitoring room where we set up, where we put multiple sensors connected to the Dropbox in order to monitor the behavior of the transmission and to make several tests, such as in the next slide, I'm showing here just results about NVH, its noise, vibration, harshness analysis in specific frequency in order to test the behavior of the machine. And at the same time, we are developing a simulation environment in order to and we are correlating the experimental results with the simulation results. And the goal in parallel to this project is to develop a simulation environment that provides us reliable test environment in order to reduce the manufacturing of multiple prototypes. So this will help a lot in reducing costs and reduce also the waste. So here is just a real image about the transmission that is now running in several real vehicles in some customer, because we have some customers who were interested in buying this machine. And in terms of timing, so in terms of design, we almost finalized the design of this transmission. We are performing the tests in lab for validation of the prototypes for several months now. So it's still in progress to make some validation tests before delivering the final results. So we have some prototypes available for customers starting from November last year. And as I was mentioning, so the production of this system to be commercialized is planned to be on Q2 for 2026. So I think this was my last slide. Thank you so much for your attention. And if you have any questions, so I'm ready to answer.
Thank you very much, Bassem, for your time and for your talk. I think we can start with the discussion session.
Yeah.
I'm not sure if you have the raising hand functionality on Zoom. If not, then I will just try to unmute.
Yeah.
We see how it works. Okay, so maybe I will start with a question. And that is being, what is the specificity of this system, of the e-trans transmission system? What makes it special?
Yeah, so what makes it special, in fact, as you can see in the slide, as I was mentioning, so still it's not clear yet to our customers if they move forward electrification of their equipment or not. So the idea is that we are providing a hydrostatic version which can be installed in parallel with an internal combustion engine. And there is no need to design a new architecture of the vehicle to embed the electric version. So at any time, the customer can move from the hydrostatic version to electrical version without big changes in their vehicle. So that's point one. The second about specificity is that this transmission can be adapted to the customer needs. So in terms of gear ratio, in terms of options, and so on. So that's mainly the specificity of this of the e-trans project.
So you develop the product upon customer request, or you have already a set of variants, so to say?
Yeah, in fact, that's the point. The e-trans project started as pure research project, and that's why we have a partner in this project, which is a public institution, the University of Luxembourg, where 3 postdocs are working in parallel with us for the development as R&D project. And it's also a national project that is supported by the state because it targets electrification and a lot of priority access of the state and Europe, its reduction of CO2. So it started as R&D project, and of course, as soon as we started also discussing and talking about this new product to our customers. And we have already now 3 customers interested in buying our system. And that's why we manufactured already several prototypes. We made some testing and validation phase. And we also sent some prototypes to be tested on real vehicles in real conditions. So it started as an R&D project, as I said, but now it's becoming, we adapted, of course, based on our customer specification and requirements. And we have now some customers behind who are interested to buy it.
Maybe some not related question, but is the interest more important in agriculture or more towards the building equipment?
It's for this one, it's mainly construction equipment.
I'm not sure if...
We have recently one request of a customer, and we are using the same transmission but in a different configuration where it's attached directly to an axle of a tractor. It's fully electric tractor, and so the thing that we added the full axle of the tractor directly connected to the drop box. So we succeeded to adapt it to agriculture, but the drop box as it is alone like this, it's mainly dedicated for construction equipment.
Mm-hmm. And is charging here being an issue for the customers, or they're...
Not really for this one. For example, in the agriculture application, the autonomy, it's for 8 hours, which is the duration needed for 1 day work.
Mm-hmm. If no one else wants to, I don't want to keep asking questions. If somebody else has a question, please feel free to just unmute yourself and speak. If not, I also have a couple of technical questions. Yeah, I guess I will just go ahead. So what kind of sensors are you using for in the transmission?
Yeah, actually, for this transmission, we are using a set of different sensors. We have pressure sensors and temperature sensors, mainly used for the oil and lubrication in order to check the needed pressure in terms of oil and the temperature. We also use the rotation specific sensor to measure the RPM for input and output shafts. We also use, for the synchro version, we are using a position sensor where it indicates the position of the fork in order to provide the information about the shifting if it's in the first or second gear.
Mm-hmm.
Yeah.
And how is you mentioned the lubrication, how is it being performed exactly?
Yeah, in fact, it's an interesting function that we considered in the system, and that's why we internally at Carraro we developed a specific mechanical component which is called gyrotor, and gyrotor is the responsible of ensuring the lubrication of the whole system. And the gyrotor can work in two different configurations. Either it can take the oil from the sump. So as you can see, the housing of the transmission, we have always the oil, like the normal transmission of the car, you have oil inside the transmission. And the gyrotor is taking the oil from the sump, which is in the housing, and then distributing the oil to the input shaft, the intermediate shaft, and the output shaft via the specific channels. And it's lubricating the whole system, including the whole components, so the gears, the bearings, and so on. We can have another configuration where the oil is coming from the vehicle itself, and the gyrotor is acting at the same way, but it's taking the oil from the vehicle. But the gyrotor system was designed and developed by Carraro to be integrated in this system, which is a new feature and a new component that was developed during this process, this project.
I have one last question, which is about the gear shifting. How to ensure that the gears are actually shifting?
Yeah, the gear shifting is for both synchro shifting or high power shifting. It's made using oil pressure. And we have an accumulator which contains the oil and specific solenoid that allows to put pressure on the shifting system, either the synchro or the power shift. And by applying oil pressure, it can ensure the shifting from first to second gear. So it's mainly hydraulic shifting based on the use of oil.
Okay, thank you, Bassem. I think I've had enough technical questions for you. If no one amongst the audience has anything to add, I just want to have your personal opinion about the potential that this technology has. So you've been in touch with some customers already, and probably some of them accepted testing, some of them are already willing to adapt this technology. But how do you see the general landscape of accepting such technology in these fields?
Yeah, in fact, the feedback is quite positive, and we see a lot of interest from our customers. The thing that uh, they started mainly targeting the hydrostatic version, and they are already asking for this system, but they are interested to test the electric version. And the thing that is a bit blocking for them is the test of the autonomy. So they need to be sure that the vehicle that they are developing can satisfy their needs in terms of work that they need to perform. And this is another problematic related mainly to the battery block and the battery system management in order to have a full system that can allow them to keep the same efficiency as they were doing using the internal combustion engine. But as I said, so they are really willing to follow this new path of electrification, and until now we have good discussion with our customers, and we see a lot of interest related to our product. So and I believe also that in terms of new laws related to electrification of medium and heavy duty vehicle, it will push more with a lot of restrictions these OEMs to move toward electrification. So I think there will be no choice than for following this
Yeah,
path.
to adapt.
Yeah.
Well, thank you again, Bassem, for being patient with these
You're welcome.
questions, and I wish you good luck with this
Thank you.
project. Check on you by the end of 2026
Thank you
to
so
see how
much.
far did you get.
Yeah. So as I said, here we have already the test bench running with a lot of prototypes being tested. So if anyone is interested to visit us, you are more than welcome. Yeah,
Thank
Luxembourg
you.
is close. Yeah, you're
Yes,
welcome.
it is.
Yeah,
Thank you very much, Bassem.
thank you.
Well, I would like to also thank the audience. And yeah, I think see you in the next session of the seminar series.
Yep.
Goodbye.
Thank you. Bye-bye.
Bye.